Hey everyone, we are now at chapter 5. We are going to be talking about rational numbers and equations. So we know what equations are. We've dealt with them for a little while now. I thought this was kind of funny. So I'm sure that's going to be pretty much review for you guys. We'll introduce some new stuff though. And then we're also going to be talking about, like I said, rational numbers. So everything in the blue circle, everything that's contained in the blue circle. So let's go ahead and get started. So we're starting with 5.1, naturally, and we're going to be talking all about rational numbers. So let's go back to that little diagram real quick, and let's just take a quicker look. Okay, so rational numbers. So rational numbers are these four right there. Okay, those would be rational, but also everything inside there is rational. And, well, why is that? Well, let's talk about the definition of a rational number. Alright, so a rational number is a number that can be written as the quotient of two integers. Okay, so we got the words, quotient and then integers. Okay, two integers. So quotient means, of course, division, and integer means positive or negative non-decimal. So if you don't remember that from before, that's positive or negative non-decimal number. Okay. So you might be thinking, well, so I just take any two numbers and divide them and I have a rational number? Well, actually, yeah. So what we're going to do is we're going to take some numbers and we're first going to prove that they're rational. So this is item number 2. We're proving Rationality, proving the rationality of some numbers, okay? So let's take the number 7. I'm going to say, you know what, I think that's a rational number. And we're going to prove that by seeing, well, okay, are there two integers, okay, two integers that I could divide, okay, quotient, that would get me 7? Well, yeah, okay, I could take 14 and divide that by 2. And if I take 14 divided by 2, I get 7. Therefore, 7 is what? Well, it's rational. Okay. Well, how about negative 8? Is that rational? Well, let's see. If I took negative 8 and divided it by 1, I would get negative 8. Therefore, negative 8 is also rational. Well, how about 5 3/4? Is that rational? Well, let's see. If it's rational, it means I can write this number as the quotient of two integers. So it's going to look like some number divided by another number. And if I can get something there that is the same as that, then it means this is rational. Well, we have a mixed number. Remember, we can write mixed numbers as improper fractions. So that's like saying 4 times 5 is 20, add 3. That would be 23 divided by 4. And you know what? Now I have the quotient of two integers because I have two integers, one on top, one on bottom, and then I have division right there. So guess what? 5 3/4 is also a rational number. All right, so let's talk about some of what we have here in this diagram. Okay, so everything in this whole diagram is a real number. Okay, so we have both rational numbers, which is everything in this largest oval there, and then we have irrational numbers, which we're not going to quite get to, but pi is probably the most famous one, okay? And you'll understand why these things are irrational once we understand why all these are rational. So the smallest thing in there is what you see there is natural, okay? A natural number. And a natural number is just a counting number. And like it says right there, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth, okay? They're positive. They're integers that are positive, okay? So then the next thing we have is whole number, okay? So notice that a whole number, inside that yellow circle, we still have the red circle, okay? So the only difference between a whole number and a natural number is that a whole number could be 0, okay? So a whole number would be definitionally 0 and positive non-decimal numbers, okay? So if I gave you the number 4 and I said, classify that. Well, you would say, well, it's both a whole number, but it's also a natural number. It's both of those things, okay? So next we have integer, and if you notice inside the green integer oval, we have both natural numbers, we have whole numbers, but also integers can be negative. But what do you notice about all these negative numbers they have right there? If you're looking at a small screen, maybe this helps, okay? -1, -2, -3, -4. All of those, okay, that goes on, -5, -6, -7, -104, -221, blah, blah, blah. They are all what? Well, they're non-decimal numbers, okay? So an integer is a positive or negative non-decimal number. So if I gave you the number -7 and said classify that, well, you would say, well, you know what? -7 is an integer because it's a negative non-decimal. But is -7 a whole number? Well, no, it's not. Our whole numbers are 0 and positive non-decimal numbers, okay? Is it a natural number? Well, no, natural numbers start at 1 and they go up by 1. 1, 2, 3, 4, 5, 6, so on and so forth. So -7 is an integer, all right? But it's not a whole number and it's not a natural number. Okay, so the other thing we have here are just rational numbers. So let's get the definition of that again, which we said up here was a rational number is a number that can be written as the quotient of two integers, okay? So if we look at our diagram again, we have -4/3. Well, -4 is an integer and 3 is an integer. And if you put one of them over the other, you have a rational number, okay? Now, also we have this though, 1.3 repeating. Well, that's interesting because that's different than anything else we've encountered, so we'll talk about that. And then we also have 11/2. We haven't talked about that yet, so we'll get there in a second. But notice that everything inside this, okay, is a rational number. So if I gave you the number 1 and said classify it, well, 1 would be a natural number, okay? 1 would also be a whole number. 1 is also an integer, and it's also a rational number. Okay, so let's talk about these couple other types of rational numbers that we have. So the first one I think of is terminating decimal. Okay, so think about what terminate means. Well, it ends, right? Okay, so a terminating decimal is a number that eventually has a remainder of 0. Okay, so 3.79 would be a great example of a terminating decimal. It is a number that doesn't have a decimal that continues on, right? 3.79 stop. All right, so if we wanted to kind of look at one of those, practically speaking, if we took 11 divided by 2, okay, like right there. Well, let's see. If I did 11 and divided it by 2 with long division, I'd say, well, okay, 2 goes into 11 5 times. So then I get 10, subtract, and I get 1. So I have to do a decimal there, and have a 0 and bring that down, okay? So 2 goes into 10 5 times. That's 10, subtract 0. I have a remainder of 0. Okay, so 11/2 is a terminating decimal because what the 11/2 really means is 5.5, right? 5.5 stop, terminating decimal. Now the other kind of decimal we have that is a rational number is a repeating decimal. All right, so a repeating decimal would be a digit or a block of digits that repeat without end, such as 0.3 repeating. Well, why? Because that really means 0.33333, so on and so forth, right? Another example would be 0.45 repeating. What does that mean? Well, it means 0.45454545, ... so on and so forth. You get the idea. So both terminating decimals, okay, decimals that end, such as 5.5, and repeating decimals are rational. So we've talked about all these different types of numbers that are rational. So what does that leave us with? Well, it leaves us with irrational numbers. Okay, now both rational numbers, which we've talked about, and irrational numbers are real numbers, okay? But the irrational numbers, just really quickly, you know, we said pi was an irrational number. So if you hit the pi button on your calculator, what you get is 3.141592655 4, and it looks like it ends, but actually we know that pi doesn't end. Okay, that number continues on and on and on, and so we actually say that pi is an irrational number because it's a decimal that doesn't have an end. Similarly, if you do the square root of 3, like it says right there, you get 1.7320508808, and you know what? There's no pattern to that, and it doesn't repeat, and it doesn't actually end, even though your calculator ends at an 8. It continues on and on and on. And so what we also say is that the square root of 3 is an irrational number. Same thing with the square root of 5. There are lots and lots of irrational numbers, so just so you know, that's what those mean. But we're really focusing on these rational numbers again. Natural numbers, whole numbers, integers, and these rational numbers, which include all those things, also repeating decimals and terminating decimals. All right, so let's call all those definitions there item number 3, and so we'll move on to item number 4. We're just going to practice with rational numbers. What I want you to do is I want you to write this fraction, okay, as a decimal. And so let's start with 4/5. Write that as a decimal. So pause the video, try that, play it when you're done. All right, so hopefully you saw that. Hey, you know what? These are two integers, and there's a division sign right there, or a fraction bar. So it's the quotient of two integers. We're going to have a rational number, and that rational number will be, well, let's see, that means 4 divided by 5. 5 can't go into 4, decimal, decimal, and the 0. 5 can go into 40, though, 8 times. No remainder, 0.8 would be our answer. Item number 5, how about 2/9? Well, okay, that means 2 divided by 9. So 2 is inside the fraction bar, 9's on the outside doing the work. 9 can't go into 2, but I'll do a decimal, decimal, 0. 9 can go into 20 2 times, which gives you 18, so subtract, and you get a 2. Well, let's bring down another 0. 9 can't go into 20 completely, but I can go in 2 times, that's 18. Subtract, we get 2. Okay, another 0. Let's bring down. 9 goes into 20, not quite all the way, but it goes in 2 times 18. Subtract, and oops, that should be a 2. And what are we noticing? Well, we have what? A repeating decimal. Okay, every time you bring down a 0, you're going to get a remainder of 2. So this is a rational number because it's a repeating decimal. Right? That repeating decimal would be written 0.2, the repeating sign over the 2. All right, so the last thing we're going to do is I'm just going to have you pause the video, and I'm going to have you prove that a number I give you is rational, and then I want you to classify it. All right, so there you go, 4 1/3. Go ahead, pause the video, prove that the number is rational using the method we talked about, and then classify it. What type of rational number is it? Is it an integer? Maybe it's not. Maybe it's a natural number. Maybe it's both. Go ahead and try that. All right, so let's worry about the proving part first. Now, how do we prove that a number is rational? Well, if I can write the number that I'm given, 4 1/3, as the quotient of two integers, then you know what? It's rational. So, how can I write 4 1/3 as the quotient of two integers? Well, that's just a kind of more complex way of saying, can I write it as an improper fraction? Well, yeah. 3 times 4 is 12, plus 1 gives you 13 over 3, right? 13 over 3. So, therefore, 4 1/3 is rational because I've just written it as the quotient of two integers. So now we need to tell, okay, well, let's see. What kind of rational number is it? We have lots of kinds of rational numbers. So let's see, 13 divided by 3. Well, in order to classify it, I need to know, well, I know it's positive, so that helps a little bit, but does it have a decimal? Well, it's a fraction, so it's probably going to have a decimal, so let's see. 13 divided by 3. Well, let's see, 3 goes into 13 4 whole times, giving you 12. Subtract, that leaves you with 1. Decimal, decimal, 0. Bring down the 0. 3 goes into 10 3 times. So that gives you 9. Subtract and a 1. Bring down another 0. 3 goes into 10 3 times. Gives you a 9. Subtract and you get a 1. And if we keep doing that, what's going to happen? The same thing, right? So 13 thirds, also known as 4 1/3, can be written how? Well, 4.3 repeating. Okay, 4.3 repeating. And you may have been able to tell that from just looking at this. Maybe you knew 1/3 was the same as 0.3 repeating, so you knew that 4 1/3 is actually 4.3 repeating from the very beginning. Maybe not. Either way is totally okay. So the question is, what type of rational number is it? Or is it just a rational number, but it's not an integer or a natural number or a whole number? Well, let's go back and look. All right. So inside the rational number oval, we have natural numbers. Well, it's not a natural number because it has a decimal. It's not a whole number because it has a decimal. It's not an integer because it has a decimal. But it is rational, right? It's one of those rational numbers that is only rational, but it's not a natural, a whole, or an integer. But it is a rational number, and we have just proved it by writing it as a quotient of two integers and classified it as just plain rational. All right, guys, that's all I have for you. Thanks for sticking with me. Look forward to seeing you in class.